Today I'm going to show you about the last project of the year for physics, which is called the Real World Physics Project. To access all the information you need to get started with this project, you're going to start at our Haiku homepage, and you're going to go down to the bottom of all the blocks of the content that we've done throughout this year to the project link. On the project link, you're going to see that there's pretty much all the projects we've done so far, last of which is Real World Physics. If you click on the Real World Physics link, it's going to bring you to the web page, and this is the only real page that you're going to need to get started. Now, the task is thinking about your future and understanding what we've done so far in this year, which has covered a wide range of physics topics, starting to look into and starting to think about your career. Your goal in this project is to look at all of the activities and all of the jobs and all of the careers that utilize physics to some degree. You're going to, with a partner or with a small group, choose a career, and then you're going to research all of the aspects of this career. If you look at the process link, this goes through the detailed step-by-step approach that you're going to take, but the first thing they're going to do is you're going to work together with your group to begin to choose a career. To do that, I've given you a graphic organizer that lists and has a lot of good examples of different fields that you can choose from, and then more specific careers that all utilize physics to some degree. Using this career wheel, you can decide what kind of area you'd like to focus on, and then more specifically, what kind of a career would you like to investigate. Once you've looked at that and decided on a career, you're then going to print a graphic organizer by clicking here. The graphic organizer is pretty much where you're going to put your research. In each of the boxes, you're going to be figuring out all of the different factors that you would need to accomplish to be able to do this career. You can explain the career in a little bit of detail. Where it says education needed, it's what kind of degree would you need, are there any certification tests you need to take, etc. For ability is a little bit vague, but for some specific careers, there are certain abilities you need in terms of being organized, having good visual spatial skills, things like that. So different careers may have more or less abilities than others. The next is location. Some careers can only be done in certain locations. If you're a research scientist, there are certain areas where there are physics labs. There are some careers, though, that could be done pretty much anywhere. So it depends on your career. For physics concepts involved and math concepts involved, this is going to be a bulk of your research. A lot of the physics, now that you've learned a lot, is probably going to be pretty logical and pretty self-explanatory. But you're going to want to, for your particular career, explain how those particular physics concepts that we've learned throughout the year are utilized. Same thing goes with math. What levels of math do you need to be competent in? What levels of math are you using on a daily basis based on that career? Technology involved and technology gained. These two sound very similar, but they're actually really different. Technology involved is what kinds of technology do you use to be able to do that job on a day-to-day basis. Okay, for example, as a physics teacher, my technology that I use would include lab equipment. It would include my laptop and PowerPoint and the overhead projector, things like that. Technology gained is new things in the field, or it could be things that we have gained from having this career. Okay, so for example, technology gained in the teaching field would be something like having iPads in the classrooms, having smart boards, okay, and how they help not only just that profession, but how they also help others that are utilizing that profession, okay? This is going to be handed in and checked prior to your actual video project because it's a way of checking that everybody's on track. On the back of the sheet or on a separate sheet of paper, you should have listed all of your sources. That's going to be put into your works cited. Also in the process link of this website, you'll see that I've got some good sources to get started depending on what field that you're interested in researching. If you click on any of these tabs, you've got some good links to just as jumping off points to get started. Okay? Once you've finished all of your research, your ultimate project is going to end up being not a brochure or a PowerPoint, but a video. The video can be done as a commercial if you'd like to do it like that. Your video could also be done as a skit or as a day in the life of. It can be a one-on-one if you find somebody who's actually in that field and you'd like to interview them. Or it could be done with you guys acting as if you're in that field. Okay, totally up to you. The video should be, I would say, between 7 and 10 minutes. And it's going to be presented on the due date. Now you can check and see how you're going to be graded if you look at the rubric. You can print this out if you need to by clicking here. Okay. Once you've completed your project, you're going to click down here on this link of the rubric page. And it's going to bring you to one more link that you can click for your reflection questions. Every person in the group individually is going to be answering reflection questions, reflecting on the type of research project that this project was. And my goal is that you'll start really thinking about not necessarily a career in physics, because not everybody's going to do that, but careers in general, what's going to happen once you get to college in a year, and where your life's going to be leading. Okay? Good luck as you start your journey, and start to think about how physics affects pretty much every job that you can think of.